Okay, we have here today another integral from the MIT Integration Bee 2006, problem 25. We have the integral from 0 to 1/2, 1 over square root x minus x squared dx. Okay, the first thing I noticed here is just that what we have inside the radical here, this is going to be factorable. I could actually factor this. I can just factor an x out of this and write this as 1 minus x. But then what I can do from there is I can kind of actually just split this up and write this as square root of x times square root 1 minus x. And then I'll just go ahead over here and rewrite this. But what I'm going to do is I'm going to take this square root of x and I want to bring it into the numerator. So what I can do is write this as x minus 1/2 in the numerator, dx over this square root 1 minus x. And what I'm trying to do here is a u substitution. But just notice if I do my u substitution right now for 1 minus x here, the derivative of this is minus 1. I don't think it's going to work very well with x minus 1/2. So what I can do actually, let's get rid of this. And then here for the minus x, I'm just going to rewrite this. I'll write this as minus x. I'll create this as x to the 1/2 and write it as x to the 1/2 squared. But then now when I do a u substitution, I'll just make it for this piece right here. We'll call our u, I'll come over here, we'll call our u equal to x 1/2. I'll differentiate using the power rule, so du is going to be just 1/2 x minus 1/2 dx. Well, then we have this part already in our numerator. I can just create the 1/2. So what I'll do is I'll multiply by 1/2 here, multiplying out front by 2. So we're just multiplying by 1. And then I'll go ahead and we'll do the substitution. So we'll have our 2 out front. So first, evaluating 1/2 at x to the 1/2, I can put this back and write this as square root x. So the square root of 1/2 is going to be just 1 over square root of 2. And then taking 0, square root of 0 is just 0. And now the numerator is just going to be du. And we can transform the denominator. This is going to become square root 1 minus u squared. But now integrating this right here is just going to be arc sine. So going ahead with this, when we integrate, we're going to have, this is just going to become 2 arc sine of u evaluated from 0 to 1 over square root of 2. So let's just evaluate it. I've got the 2 up front. Arc sine at 1 over square root of 2, or you could actually write this as square root of 2 over 2. That value is going to be just pi over 4 minus arc sine at 0, that's just 0. So multiplying 2 times pi over 4, we get our final solution of just pi over 2. Okay, there you have it. Quick integral from MIT 2006. Thanks everyone for watching. Have a good day.